A cab company charges a flat rate of $2 plus an additional 50 cents for every mile traveled. Write an expression that can be used to determine the total cab fare for a distance of m miles. Well, first of all, when you're writing expressions or equations, you want to look for three special words: per, each, or every. Because it kind of helps you to write the whatever it is, expression or equation. Now, this is an expression. The difference between an expression and equation is an expression does not have an equal sign, an equation does. So here we have one of those special words, every. Now what the special words do, what they tell you to do, is whenever you're writing your expression or equation, the number in front gets stuck to the letter behind it. So I'm going to remember that as I read this sentence again. A cab company charges a flat rate of $2 plus an additional 50 cents for every mile. But because the 50 cents and the every mile has one of those special words in between it, I stick the 50 cents and the m together. And that is the answer to this problem, right? An expression that can be used to determine the total cab for a distance of m miles. So the next one says, when Sarah arrived at her destination, her cab fare was $7.50. Write an equation, so this is going to have an equal sign in it, to represent this situation. How many miles did Sarah travel? So we have our expression, which she paid $2 plus 50 cents for every mile, but we know that all that cost her $7.50. So we actually have to, this is the first answer, part of the answer, write an equation to represent this situation. Now we have to solve it to figure out how many miles she traveled. So what you want to do is you want to, if you have your paper and your finger, whatever is stuck to the letter, you kind of want to cover that up with your finger. I can't use my finger on the board, so I just white it out. That tells you what you need to get rid of on that same side of the equal sign. We have to get rid of a 2. Now you get rid of 2's with opposites. So the opposite of positive 2 is negative 2. So I'm going to take and put a negative 2 on each side, and I'm going to put that under my numbers, like this. So opposite operations cancel. I bring down my 50 cents times m equals $7.50. This is like take away $2, so that's going to be $5. Now this is 50 cents times m, because when they're stuck together it's multiplication. So times, the opposite of times is divide. Now notice I'm not putting a negative 50 cents down here. If you start changing the sign, if you put a negative instead of just the 50 cents, you just change division to subtraction. You don't want to do that. So we're just dividing both sides by 50 cents. So opposite operations cancel. So I get m equals, and $5 divided by 50 cents is 11. I think it's 11. Let me check. It's 11. So Sarah traveled 11 miles. Okay, the next one, the cab company runs a promotion on holidays. The flat rate and the fee per mile are the same. So that's going to be the 2 plus the 50 cents are the same, but there is a $1 discount off the fare when the distance is traveled greater than 10 miles. How can you modify the expression you wrote to represent a holiday cab fare for a distance greater than 10 miles and explain? So here's what we're going to do on this one. You have to make a stipulation, because when you have to say, because let me see, greater than 10 miles. So you have to say when m so when the miles is greater than 10, when m is greater than 10 miles, the fare is reduced by $1. So that means the expression would be the original expression, $2 plus 50 cents every mile, but you're going to take $1 away. Now at this point, I hope you can see that the numbers not the m, but the actual numbers, the constants, you can take care of those and combine them. $2, and you're going to take $1 away. So that really means you're only going to pay $1 plus 50 cents per mile. So that is the new expression. That's how you can modify the expression. And when we stipulated that m is greater than 10, we were explaining why we were doing that. Okay, the next one. Lupe's cab fare on a holiday was $7.50. Did Lupe travel more than 10 miles and justify your answer? Well, if you noticed that here was the original one, 2 plus 50m equals $7.50. We know, because we solved it earlier, that this means 11 miles. Therefore, it means he traveled. He had to have traveled. Lupe had to have traveled at least 11 miles. And then it says, well, how many miles did he travel? So we know if he traveled at least 11 miles, let's put that in. 2 plus 50 cents per mile equals I apologize because I was using the wrong one because it said Lupe, he did travel on the holiday. So I don't want to use the 2 there, I want to use the 1. So what I want to do is the same kind of thing you did before. You cover up the 50 cents M because that's where the letter is. And the letter, you always deal with the letter last. So if you have it on your paper, you can cover it up with your finger. We have to get rid of a positive 1. So again, you do the opposites. The opposite of positive 1 is negative 1. So I am going to subtract 1 from both sides. And that's $1. So I've got 50 cents times m equals $6.50. Now this is 50 cents times m, so the opposite of times is divide. So I divide both sides by 50 cents and opposites cancel. And $6.50 divided by 50 cents is 13. So Lupe traveled 13 miles. Okay, Manuel's age is twice Gupta's age minus 5. The sum of Manuel's age and Gupta's age is 31. Let G represent Gupta's age. You can solve the equation 2G minus 5 plus G equals 31 to find G. Which property would not be used in solving this equation? Okay, addition property of equality, it just means you add to both sides. Commutative property of addition, that just means you combine terms. Like terms. Division is dividing on both sides. And subtraction is obviously subtracting. We want to find out the one that we're not going to use to solve this. So if we have 2G minus 5 plus G equals 31. Okay, the first thing I'm going to do is look at the left-hand side of the equation, and this G The g's can go together, and if there's nothing in front of a letter, it's assumed to be a 1. So 2g plus 1g is 3g minus 5 equals 31. So what we just did there was the commutative property. We combined like terms. So we did use that one. We're asking for the one that we did not use. Now the next step would be to cover up the letter to figure out what you need to do next. We have to get rid of a negative 5. The opposite of negative 5 is positive 5. So we are going to have to add 5 to both sides. So let me do that. Because the opposites are going to cancel. So 3g equals 36. We added. So we're looking for the one we did not do. We did add. Okay, now this is 3 times g, so the opposite of times is divide. Opposite operations cancel. 36 divided by 3, we divided. So the one that we did not use was the subtraction property of equality. Let's see if that was it. Oops, nope. How old is Manuel? Well, Manuel, let's see. The sum of Manuel and Gupta's age is 31. So M plus G equals 31, because sum means add. But we just found a value for G. We know that Gupta is 12 years old. So M plus 12 equals 31. So if you cover up your letter, because you saw for it last, we have to get rid of a positive 12. The opposite of positive 12 is negative 12. So I have to subtract 12 on both sides. Opposite operations cancel. So M equals 19. So Manuel is 19 years old. Okay, write an equation. An equation has an equal sign that requires at least 3 steps to solve, and whose solution is x equals 3.5. Okay, you could have a bunch of different answers for this. Here's what I came up with. 5x minus 1 equals 3 times x plus 2. Because you're going to get rid of parentheses first, so 5x minus 1 equals, you have to distribute 3x plus 6. So then you have to get your x's together. I'm going to subtract 3x from both sides. I always move the smallest one over if I can. So 2x minus 1 equal, opposites cancel, 6. Add 1 to both sides. So 2x equals 7. Oops, sorry, 2x equals 7. Divide by 2. So x equals 3.5.